So in this video, I wanted to do some more with Trapezoid Rule, a little bit more as far as application of it goes, more typical way it gets used. So here we're looking at the top down on a pond. So this is the surface of the pond. And every 20 feet, we're given measurement across. So at the beginning, 0 feet across, 20 feet over, 15 feet across, 20 feet over, 32 feet across, and so on. And we're told the average depth of this pond is 10 feet. If we want to find the volume, the idea of it is very much like finding the volume of a prism, where if we can find the area of the base, this shape, and multiply by the height, the 10-foot depth, that will give us the volume of this pond. Well, the issue here is there's no formula to give us the exact area of this pond surface, so we need to estimate it. We could estimate using rectangles with RAM, either LRAM or RRAM, like we've done in the past. But trapezoids will give us a better estimate with the same number of shapes than rectangles would. So I'm going to use trapezoids for this. So that means my first trapezoid would be between the 0 across and the 15 across. And while I know that's a triangle, that's also a trapezoid where one base is 0. So the area of that would be 1/2. The height is the distance between the bases, which we're told there's 20 feet between each of these. So the height of the trapezoid is 20, and times the sum of the two bases. And then if I move on to the next trapezoid, that's between the 15 and the 32. The height is again 20 feet, and then times 1/2 times the sum of the two bases. And I can keep going through with each of these intervals here. I'm just going to write out all of our areas here. Oops, not 44 there. Got ahead of myself. Oh, accidentally erased a little bit there. So 1/2 height is 20, bases are 44 and 46. And so when I multiply this all out, I get that the area of the surface of the pond is going to be about 4,060 square feet. But again, that's just the surface. I want the volume, so I need to take the area of that surface times the 10-foot depth. And that tells me then that the volume of the pond will be about 40,600 square feet. So the other example I went through is if we look at data for temperature readings taken outside every hour from noon until midnight. And we want to find the average temperature over the 12-hour period. The instinct is to just do what you've always done from grade school up through now, which is to add all of these up and divide by how many there are. So just add up all the temperatures, divide by 13. However, that's not going to work. Two ways to know. One, it doesn't really explain why, but you're preparing for the AP Calculus exam. If you find yourself on an AP Calculus exam not doing calculus, you're not doing it right. And so if you're not doing calculus to answer this, you're not doing the question right as far as the exam is concerned. The more important reason that actually explains why just adding them up and dividing by the 13 would be wrong is when I talked about average value and introduced how it's 1 over b minus a times the integral from a to b of the function, is that the way you learn how to do it in grade school, it relies on discrete data, where there are unconnected points. Well, with temperature, if we start at 63 and go to 65, those are not unconnected. We have to hit every single temperature in between. So the key here is that this is continuous. And because it's continuous, we need to do this using our average value with integrals. So we're going to be finding the average value of the temperature which will be the integral from a to b. Whoops, completely missed the first part of it. The 1 over b minus a times the integral from a to b of the temperature, which is with respect to time. Well, we know that a is going to be 0. We know that b is 12. So that would give me 1 over 12 times the integral from 0 to 12 of my temperature function, which is continuous. Well, the issue here is we don't have an equation for temperature. All we have is data. So we're not going to try and figure out the equation for temperature, because what we'll do instead is we can estimate this integral. Because if you remember, the very first way we learned how to evaluate integrals is by using areas. And we learned using rectangles. But now we've learned that trapezoids will be a better estimate with the same number of shapes. So we're going to estimate this integral with the trapezoid rule. So 63 and 65 would be the bases. They're like on our pond example, the distances across the pond. The distance between those bases is 1. So this integral, so I still have my 1/12, and then the estimate for my integral, I have 1/2 times the height of the first trapezoid times the sum of the bases. And then when I move to the second trapezoid, 1/2 height of the trapezoid times the sum of the bases. And I'm not going to write all of these out, just all the way up to the last trapezoid here. And then if we go ahead and figure out all of the areas of all these trapezoids, and then divide by the 1, or multiply by the 1/12, we get that the average value for the temperature will be about 65.167, then whatever units this is. Since these are outside temperatures, and we're assuming we're on Earth, this is probably Fahrenheit. But if it were on Mars, this would probably be Kelvin. If this was on Venus, this could be degrees Celsius. It just kind of depends where, so I'm not going to worry about the units. To give you an idea of then what if we had done this incorrectly, if we had added the temperatures up and divided by how many? In other words, if we had treated this as discrete data rather than continuous data that temperature is, we would get an average of 64.692. So we're actually almost half a degree off in terms of our average value. And the reason there's a difference like this is because this is continuous, doing it with the integral, even with an estimate, is taking into account what's happening to the temperature between, say, the 63 and 65 degrees. Whereas just adding these up and dividing by 13 is saying we have 63, we have 65, it's never the temperatures in between. So we have to make that distinction that this is continuous so that we can take into account the temperatures in between the 0 hour reading and the 1 hour reading.